Okay, this is the fourth video lesson on chapter 3, that is metals and nonmetals. Today we'll be discussing on page 50 and 51, and the heading is we are going to discuss properties of ionic compounds. Now, before we discuss the property of ionic compound, I think in the last video we said a compound broadly we can classify into two categories: ionic compounds and covalent compounds. Covalent compounds are generally formed by sharing of electron. That means it contains covalent bond, whereas ionic compounds are formed by transfer of electron. Transfer of electron meaning losing and gaining of electrons, and it contains ions. That means since there is a losing and gaining, so the atom which loses electron will become positive charge, and the atom which gain electron will become negative charge. So ionic compounds contain ions. Ions, we know there are two types of ion: positive ion and negative ion. And between these two positive ion, since the charges are opposite, there will be force of attraction. Force of attraction. So this point you have to remember. So I'll be repeating. Ionic compound contain ions. Ion, there are two types, positive and negative. Positive ion, before also we said, is called cation, and negative ion is called anion. And between opposite ions, there will be always force of attraction. Now, if you ask between same ion like positive or negative, then there will be force of repulsion. But in ionic compounds, the ions are arranged in this pattern: positive, negative, just to make sure the force remain attraction. Okay, so first point the first physical property that we are going to discuss is physical nature. Now, since in ionic compounds there will be ions, and ions will be always arranged in opposite charge. That means positive will be near to negative will be near to positive, like this. So inside ionic compound there will be very strong force of attraction between the opposite ions, and because of that the ions will be tightly packed, or they will be very close to each other, and this result into solid. So ionic compounds are generally solid, and it is a hard solid because the force of attraction between the ion is stronger. So physical state, under physical state, what we are going to say, ionic compounds are generally hard solid. Now, why they are hard solid? The answer is because between the opposite ion there is strong force of attraction. So due to strong force of attraction between opposite ion, means between positive ion, which is called cation, and negative ion, which is called anion. But one point you have to remember: okay, in spite of hard solid, the ionic compounds are brittle. That means when you apply force, it will break. Now, why it will break, it is not explained in the textbook, but some logic we can find. Suppose these are the atoms arranged like this. Suppose this is positive, negative, positive, negative, positive. So next. So this will be negative, positive, negative, positive, negative. So, like for example, between these two opposites, so attraction, between these two also attraction, between these two also attraction. So what happened when we apply strong force? What happened? This layer will slide down. So when force is applied, this layer will move down. This layer move down. Then suppose if this is going little down, then negative is coming here. Suppose this whole thing is moving down one step, suppose moving down. Okay, how many steps? It depends on how much force we are applying. So when we apply force, the layer may slide, and there is a great chance that same charge may come nearby. That means same type of ion will be aligned nearby because of the strong force, and when same ions are nearby, then the force changes from attraction to repulsion, and due to this the whole layer will break or separate because of repulsion, because same ions are coming closer because of the force applied on any ionic substance, and due to this it is breakable or brittle. But this is not mentioned in our textbook. Just for extra information, you can remember like this. Okay, next is melting and boiling points. So what we can say about the melting points and the boiling points. Now, before that, you should know what is melting point and what is boiling point. So let me say the sentence. Melting point is the temperature at which solid turn into liquid. Similarly, what is boiling point? Boiling point is a temperature at which liquid turn into gas or start boiling also, we can say. Now, suppose if you want to change solid into liquid, what we have to do? We have to supply heat. So when we supply heat, what is the function of this heat? It will increase the gap between the particles. Here the particles will be atom or ions, we can say. So to increase the gap between ions, and between ions we have strong force. So due to this, what happened? Too much heat is needed to increase the gap between the ions, so that the solid turn into liquid. Because if you want to turn solid into liquid, the gap between atoms or particles has to be increased enough. And for that, very high temperature is needed. That means too much heating you have to do. Then only the gap between ions will increase, because ions are strongly held by strong force. So since too much heating is needed, so answer will be generally ionic compounds has a high melting and boiling point, since too much heat is needed. Okay, so under melting and boiling point, we can just say that the other name of ionic compounds, ionic compounds are also called electrovalent compound. The other name of ionic compound is electrovalent compound. So melting and boiling point. So what we can say that they have generally high melting and boiling points. So ionic compound, if you want to write the other name, you can say electrovalent compound, have high melting and boiling points. Now, if you want to explain why they have why they have high melting and boiling point, the reason will be this is because a considerable amount of heat is required to overcome strong inter ionic attraction. That means between ions there will be a strong force of attraction. So if any solid wants to melt or liquid wants to boil, too much heat is needed, then only the ions will go far, because they are having strong force of attraction. Okay, property number 3, solubility. Now, ionic compounds are generally soluble in water but not soluble in organic solvent like kerosene, petrol, etc. Now, for solubility, the rule is like this. Ionic compound means they have charge. So, ionic compound will dissolve in a solution where charge is there. So, water, if you see the bonding of water, so water formula is H2O, and water bonding is like this. Water oxygen will form two covalent bond with two hydrogen. Now, since water is having covalent bond, so by rule, it is covalent compound. That means ionic compounds should not be dissolved here. But there is another theory. Okay, this single covalent bond contain two shared electron, one from hydrogen and one from oxygen. Similarly, this single covalent bond represent two shared electron, one from oxygen and other one for hydrogen. Now, if you go in higher classes, then you'll find that oxygen has a high value of electrical negativity, and hydrogen has low value of electronegativity. In simple way, in class 10 level, we can just say that these two shared electron, they are supposed to be in the middle of H and O, but since oxygen has more liking or more attraction for electron, this shared electron will go little near to oxygen, and because of that the oxygen will develop small negative charge. Small negative charge is represented by adding a sign delta here, and the hydrogen will be getting small positive charge because this shared electron are going, in place of staying in the middle, it is going little near to oxygen. Same way this also. So in spite of water having covalent compound, it has slight charge. That means it become polar solvent. Polar solvent means they have charge, and because of this it is able to dissolve ionic compound. So ionic compound will dissolve in a liquid where charges are there. But kerosene, petrol, these are pure covalent compound and they do not have charge like water. That's why this ionic compound are not able to dissolve in organic solvent like kerosene or petrol, because they have only covalent bond. They don't have charge. That means even polar charge, slight charge also is not there. Water is also covalent compound, but water is polar molecule because the shared electron are not in the middle. It is shifting towards the oxygen. That's why weak negative and positive charge are developed. Okay, next point is number 4. Number 4 heading is conduction of electricity. Under under conduction of electricity, look here, ionic compound will conduct electricity or not. Look here, the rule is that to conduct electricity, ions must be present. Not only present, the ion must be able to move. So ionic compound contain ions, but if it is in solid form, then the ions are tightly packed, and that means the ions are not able to move. So ionic compound cannot conduct electricity if it is in solid form. But if it is in solution or it is in melted form, that is a molten state, then it will able to conduct electricity, because in both the cases, maybe solution or maybe molten form, the ions will be able to move. And if ion can move within a substance, then that substance become a good conductor of electricity. So ionic compounds conduct electricity in aqueous solution or in molten meaning is melted state, because as in both cases ions are free to move to conduct electricity. So generally we say ionic compounds are good conductor of electricity, but for that condition is that it has to be in solution or in melted, that is molten form, so that ions can move, then only it can conduct electricity. In solid form, ionic compounds cannot conduct electricity. So in our textbook, these 4 points are mentioned under physical properties of ionic compound. For covalent compound, nothing is explained. So covalent compound, no point of comparing. So we'll see the next heading. Right. So corrosion is a process in which metal, in very crude language, we can say metal spoil. Spoiling word generally it is not used for metal, but if you cannot remember anything, you can say the process of spoiling metal, or the process of deterioration of metal, or the process of metal changing into undesirable substance by the chemical reaction with their environment. That process is called corrosion. So if you're thinking to write a definition, then let us try one definition. The process of slow conversion of metals into undesirable substances by reaction with their environment is called corrosion. Now, if you cannot remember this, then you can simply say that wasting away of metal, or wearing away of metal, or very crude language, spoiling of metal in environment, that is called corrosion. Okay. Now, corrosion and rusting, if you want to compare, then let us see corrosion in this manner. Corrosion, the term corrosion is used for all metals. For all metals, can be used for any metals. So let us classify corrosion into two categories: for iron and for metal other than iron. Now, if the corrosion is for iron, that corrosion is called rusting. And if the corrosion is for metal other than iron, then no name is given. No name means you have to say simply corrosion. So corrosion we can use even for iron also, because it can be used, corrosion term can be used for any metal. It can be used for all the metals. So we are classifying, okay, for metal other than iron. Okay, this no name, let it be no name, because here we say corrosion for all metals. So no specific name is given. That means if there is no name, we can use corrosion. Even for this also we can use corrosion. But when you say rusting, you are, because when you say corrosion, then you are not telling which metal is spoiling or which metal is deteriorating. But when you say rusting, you are indirectly telling the name of the metal. So rusting means corrosion of iron. So rusting means corrosion of Iron. So rusting carry two information. Rusting means okay, it is a corrosion, but indirectly you are telling it is iron because the word rusting you cannot use for other metal. If iron is spoiling, okay, you can say rusting. But don't think that iron is the only metal which can spoil, like copper also can spoil. So when copper spoils, something brown is not produced, something green is produced. So when copper is spoiling, you can't say rusting. You have to say corrosion. Only for iron, a special name is given called rusting, and for all the other metal, no name is given. That means only you have to use corrosion. Even for iron also we can use corrosion, no problem. But there is a separate name is given, so better to use separate name for iron, and for other metal we can use corrosion. Okay. Now we'll see some corrosion of three metals. I think we'll just check. Three metal names are mentioned in our. So we'll see example of corrosion of few metals. Okay, we'll be looking whatever is mentioned in our textbook. So in our textbook is mentioned number one, corrosion. Let us discuss corrosion of silver. Under corrosion of silver, okay, when silver undergo corrosion, then a compound is produced called silver sulfide, and this compound is black in color. So on this, one question may be asked: when silver is exposed in air, then slowly it become blackish. That means silver when it is new, it will be shining, silver color will be there. But after using for some time, silver metal start turning into little blackish type. So what is the reason? Because silver will react with the sulfur in the atmosphere and it become a compound called silver sulfide, which this compound is black in color. That's why it give a blackish look. Okay, reaction is not in the textbook, but we can just write if you have to practice. So silver article become black after some time. This sometime does not mean a few hours. So sometime means a few days or few weeks, we can say, when exposed to air due to formation of silver sulfide Ag2S, which is black in color, or due to formation of a black coating of silver sulfide, also we can say formation of black coating silver sulfide. And this we can do full stop here. Reaction is not in a textbook, but if you want to know reaction for general knowledge, so silver will react with H2S. This is hydrogen sulfide. This gas is present in the atmosphere in very small amount. So from here, sulfur will go there. So this is corrosion of silver, this reaction. So this silver sulfide will be formed and hydrogen gas will be released. So this compound is silver sulfide. And this compound has black color. So when silver react with sulfur, they are saying here, we are saying a textbook is saying the silver will react with the sulfur, but that sulfur will come from H2S. So silver will react with the sulfur from H2S and become a compound or black compound or black coating, form a black coating of silver sulfide, and due to this, silver particles slowly become black when exposed in the atmosphere. The reaction is just for information, in the textbook reaction is not mentioned. So the textbook is saying that silver will react with the sulfur present in the atmosphere, but sulfur will not be directly present in the atmosphere. Sulfur will be in the form of H2S, that means in the form of compound. Okay, number 2, it is corrosion of copper. Corrosion of copper. Okay. Copper react with moist carbon dioxide and slowly form a green coating. Green coating of basic copper carbonate. For this also, reaction is not mentioned in our textbook, but just remember this sentence. So when copper undergo corrosion with carbon dioxide and moist, meaning water molecules will be there, with moist carbon dioxide in air, that means oxygen also will be present, then it will form a green coating of basic copper carbonate. A reaction is not in the textbook, but if you want to know, then we can write like this: copper is going to combine with oxygen, it is going to combine with water, it is going to combine with carbon dioxide, then it will form a compound CuCO3 dot CuOH2. Now this compound name is basic copper carbonate. This compound name is basic copper carbonate, and this compound is green in color. That's why whenever copper undergo corrosion, then some greenish thing will be coming, not something brown, okay, not like iron. Now here basic represent this OH. Any compound ending OH is a base, so this OH represent basic. Both this copper is represented by a single word copper, and carbonate is CO3. Carbonate is CO3 is called carbonate. But again, I'll remind you, this reaction is not in the textbook, so no question will be asked on the reaction. Even the formula of basic copper carbonate, there is no chance of asking. The name you should remember, the green coating which is formed when copper undergo corrosion is what is the name of that green coating or that compound is basic copper carbonate. Okay, after number 2, that is corrosion of copper, one more metal corrosion is explained. Number 3. So number 3 is corrosion of iron. But we see if the corrosion is for iron, there is another term or word that is rusting. So when you say rusting, don't say rusting of iron, because rusting itself meaning is that it is for iron. So rusting means it is understood that corrosion of iron is called rusting. So this is more common because iron is the most abundant metal that we use in our daily activity. So we know that when iron undergo corrosion, that is rusting, some brown thing is produced, and that brown thing we say rust. So corrosion of iron or even rusting is a chemical reaction between many things. So that reaction is not mentioned in our textbook, but for knowledge we can write. Okay, so iron slowly react with moist air to form a brown compound called rust. Now, what is the formula of rust and what is the chemical name in our textbook? Chemical name is not mentioned. Okay, then for knowledge we can talk. So rusting is a chemical reaction. So in rusting, what happened? Iron will react with oxygen and react with water. Water, how many molecules is not fixed, so water will be n molecules, or sorry, x molecule. Okay, some text will say x, and also no problem. Then this reaction is called rusting, and a compound is formed Fe2O3 dot XH2O. If you want to do balancing, then here you can write 4, here you can write 2, here 3 you can write. Okay. Okay. So this compound, or if you don't do balancing, or since it is not in the textbook, so balancing is not important. Now, what is the name of this compound? Okay, this compound is called rust. But if you're thinking what is the chemical name of rust, for that you should know iron. Valency will be some compound 2 and some compound 3. So if the valency of iron is 2, that iron is called ferrous. And if the valency of iron is 3, that iron is called ferric. And if you have a confusion whether this iron will be ferrous or ferric, then you can say this is iron 2 and this is iron 3. And if you're not sure, then you can just say iron also. So this iron, okay, whenever you see valency, because whenever a formula is written, the valency is always interchanged. So Fe valency is this and O valency is this. So in this compound, the valency of iron is 3. So this iron proper name is ferric. But if you're not sure, then don't use this ferric and ferrous. You can just say iron. Okay, so if you want to write the chemical name of proper chemical name, then since there is water molecule, how many water molecule that vary from place to place? So we'll just, to represent water, we'll just use a word hydrated. Hydrated ferric oxide. Hydrated to represent water, ferric to represent the iron whose valency is 3, and oxide is to represent the oxygen. So this hydrated ferric oxide is your rust, and this is brown in color. Okay, so this is for knowledge, the name of, or what is the chemical name of rust, or what is the chemical formula of rust is not mentioned in our textbook. So you have to just remember that when iron undergo rusting, that is corrosion, it produces a brown substance which is called rust. Okay, after this, prevention of corrosion. Prevention of corrosion. Or if it is prevention of rusting, you'll be writing the same thing. So how we can prevent corrosion or rusting? So the main aim is that the metal which is undergoing corrosion, we have to protect that metal from coming in direct contact with the environment. So we have to bring some layer. Now what layer, and that vary from process to process. Simple process, what we can do, many a time we do painting of metal. So any metal, whenever we are doing painting, it is not only for good looking, it is not only for decoration, it is also for protecting the metal from corrosion, that is not spoiling. So if you put painting on any metal, because of painting, the the gases in the air or moisture will not come in direct touch with the metal, so corrosion will not be there. So basic way to prevent corrosion, some methods are mentioned in our textbook. So it is mentioned painting, and then oiling, then greasing. Okay, these are general method. Number two, we can go for galvanization. Now galvanization will be a little more important because separate question may be asked. So in galvanization, what we do, iron or steel is coated with zinc metal. Okay, so but again, generally whenever we are putting covering of a second metal, so then second metal should be generally less reactive so that the cover metal does not undergo corrosion, so that inside metal is protected. But here it is little reverse. Here what happened, zinc is more reactive than iron. Suppose you have an iron and outside cover of that iron is zinc metal. That means zinc will undergo corrosion more than the iron. Then why we are covering? Okay, there is explanation for that. Because when zinc will undergo corrosion for the first time, then zinc outer covering will turn into zinc oxide. And this zinc oxide is much harder than the pure zinc, and it does not undergo corrosion further. So explanation of galvanization is similar to anodizing. Anodizing also will is there somewhere in the textbook. So in anodizing, what happened? Any aluminium article or utensils, when it is new, then it will undergo corrosion, and when aluminium undergo corrosion, it react with the oxygen and it turn into aluminium oxide layer. And this aluminium oxide layer will not allow further corrosion of aluminium which is inside it. So because of this protective layer, the aluminium is prevented from further corrosion. So aluminium can form the oxide layer by itself, but iron cannot form that strong layer, because when iron undergo corrosion, the rust which is produced is not strong, it is powder, it comes out. And when zinc undergo corrosion, then the oxide which is produced, zinc oxide, is not powder like iron. It is hard covering and it is tough, so it is stay there. And because of that, inside metal is protected. So in galvanization, what will do? Iron and steel are coated with zinc metal. Then what happens? Zinc, when it react with oxygen, it turn into zinc oxide, which is hard and non-reactive. That means it will not undergo corrosion further. So in that way, iron or steel is protected by covering it with a reactive metal like zinc, because zinc does not mean that zinc will not undergo corrosion, but zinc, when it undergo corrosion for the first time, it becomes a zinc oxide, and which is hard and non-reactive. So this zinc oxide layer will protect the inside zinc and inside iron or steel. Okay, number third process in our textbook, what is mentioned? Okay, uh, alloying, or okay, we can say electroplating also. Electroplating. In electroplating, what we do, we put in a cover of a metal, superior metal, non-reactive metal, so that the inside metal is protected. So electroplating is a process of putting a layer of less reactive metal over more reactive metal by electrolysis. Electrolysis means with the help of electricity to protect less reactive metal from corrosion. Okay. This we are just adding this point. Is not in our textbook. Number 4, by alloying. So many a time, suppose iron, iron will undergo corrosion. In iron, if you mix a little bit carbon, then it is still it can go corrosion. But in this, if you can mix nickel and chromium, then the whole thing is called stainless steel. And this stainless steel is corrosion resistance. It does not undergo corrosion. Okay, so alloy is in simple alloy is a mixture of metals. Sometimes non-metal also will be included. So these are the methods by which we can prevent corrosion or rusting. Okay, after this we'll be focusing what is the meaning of alloy. Okay, alloy, we said it is a mixture of metals. Now, when we say metals, it means two or more, but sometimes non-metal also may be present. So, how to give a definition of metals? So, we can say that alloy is a homogeneous mixture. Alloy is a homogeneous. Homogeneous means the mixing should be equal everywhere. Alloy is a homogeneous mixture of two or more elements with at least one element should be metal. Now, if all the elements are metal, then also is alloy. If all elements are non-metal, then it is not coming under alloy. So alloy means, okay, you're making mixture of elements, but in all the elements, at least one element should be metal. Now, if all the other elements also metal, no problem. But if all the other elements are non-metal, then it is not considered as alloy. Now, what is the advantage of, okay, the question is how to mix metal. Since metals are solid, so how to mix them? So it is very simple. If you want to mix any metal, what you do, both the metals or whatever metal you want to mix, you heat separately at very high temperature so that all the metal that you want to mix turn into liquid. And when all the metal turn into liquid, then you mix all the liquids properly and then you cool it, then you'll get a solid. That solid will be having mixture of all the metal, and that solid is called alloy. So to make, okay, there are different methods. Okay, this is one of the methods, by melting, turning metal into liquid, then mixing the liquid. So this is one of the method. Other method you'll study in higher class. So many a time what happened, the alloy which we are making, uh, during mixing of metals, some new property will come out, and that new property may be good. If it is bad, then we'll not study. But if some new good properties are coming out, then that alloy will become important. It may have some use for us. For example, aluminium. Aluminium, good point and bad point. Good point is that it is very light metal. Bad point is that it is not strong. So when something is light, because to make aircraft body, we choose a substance which is light, not too much heavy. But aluminum we cannot use directly to make aircraft body because aluminum is not strong. So to overcome this problem, aluminum will be mixed with another metal called magnesium. And these two metal will make alloy. Oh, sorry, will mix with magnesium. So aluminum will mix with magnesium and one alloy will be formed. That alloy is called magnesium. And this magnesium has both good point. That means it is still light and it becomes strong because of mixing of magnesium. Now this magnesium is used to make aircraft body. So many a time when we mix metals or even some non-metals, then some new property comes out, and that may be helpful. But yes, amalgam. In an alloy, if one of the metal is mercury, then it is called amalgam. This may be important for objective. So amalgam is an alloy, but all the alloys are not called amalgam. For that condition is that in an alloy, if one of the metal is mercury, then only that alloy is called amalgam. Okay, so after this, we have to discuss a little bit about gold. Now, how purity of gold, that means gold is how much pure, how it is expressed. Purity of gold is expressed in carat. Okay, so when we say your gold is 24 carat, it means your gold is 100% pure. So 24 carat gold means 100% pure gold. Now, this kind of 100% pure gold is never used to make ornament. this type of gold is not used to make ornament, because this gold is soft and change shape easily. That means easily it will deform. So if you make a ornament with 100% pure gold, then whenever you apply little force, then the shape of the ornament will change. And again, you have to go for correction. So there'll be expenditure again. So 100% pure gold is never used to make ornament. Then to make ornament, what we have to do, we have to mix something into the gold. That means we have to mix some other metal into the gold. And how to mix? Everything, you melt it and then mix it. So whenever you are mixing, that means you are doing alloying of gold. So to overcome this problem, what we'll be doing, we'll be doing alloying of gold. That means in gold, we have to mix other metals. So in alloying of gold, what we'll do, we'll take gold, and in this gold, we'll be mixing some other metal. Now, which metal we can mix? We have generally it's silver or copper. Anyone can be mixed. So when you mix silver or copper in gold, then what happens? The gold become hard and it is suitable for making ornament. Generally for ornament, for ornament, maximum 22 karat gold is used. Less than 22 also can be used. If you want to understand what does 22 karat gold represent, so next page we'll be looking what is the meaning of 22 karat gold. So 22 karat gold, what it represent, or let us do okay, 22 karat gold. So it represent like this. In alloy gold means gold with impurities, gold with impurities like copper or silver is called alloy gold. So in alloy gold, we can 22 karat, if you want to represent, then we can write downside 24, upside 22. So out of 24 part of alloy gold, your pure gold is 22 part. So 22 karat gold means out of 24 parts of alloy gold, pure gold is only 22 parts. That means out of 24 part, 22 part belongs to pure gold, and how much part is missing, that is 2 part, belongs to that impurity like copper or silver, and 2 parts is impurities like copper or silver. Okay. Okay, one more topic or one more heading is left, which is important. Aqua Regia, which is on page 46. Aqua Regia is also called royal water. So what is Aqua Regia? It is a mixture of two acids, and this mixture has to be freshly prepared. If you prepare the mixture a few days, means 1 week back, then that may not be that much strong. So if you make a freshly prepared mixture of what? These two acid, concentrated sulfuric acid and concentrated nitric acid, in the ratio, their ratio must be 3:1. This may be important for MCQ. That means 3 part of the liquid should be concentrated hydrochloric acid and 1 part should be concentrated nitric acid. So this 3 is for this and this 1 is for this. Suppose you are making Aqua Regia 3 plus 1, suppose 4 liter, then in that 4 liter, 3 liter must be this acid and 1 liter must be this acid. Then the solution which you will get, that solution name is called Aqua Regia, which is also called royal water. And this solution is very strong, or textbooks say it is very corrosive, that is, it is very harmful or destructive. Any surface it can destroy. And generally gold does not dissolve in anything. So gold dissolve only in Aqua Regia. So this our textbook is saying gold, this liquid, this mixture can even dissolve gold. Now, if you put gold only in this acid, it will not dissolve. If you put gold only in this acid, it will not dissolve. So gold will not dissolve individually in any one of the acid. But when these two are mixed in this ratio and it is freshly prepared, then in that only the gold will dissolve. Okay.